So hi, I'm Tabriz, and today we're going to discuss chemical reactions part 2. We're going to discuss about balancing equations and so many other topics as well. So let's get started with balancing equations. So what is balancing equation? So balancing equation has a basic understanding that it comes from law of conservation of mass. What does law of conservation of mass states? Mass neither be created nor be destroyed. So let me explain here with an example. Okay, here you can see a reaction that is Zn plus HCl, which give rise to ZnCl2 plus H2. So this is a reaction. So as you already know before from the part 1 class, if you haven't watched the part 1 class, just go ahead and watch. I'll give you the link here. So these are known as reactants, and these are known as products on the right hand side, which are this. So ZnHCl, let's get started with breaking down these things. So Zn, we can see on the reactant side it is only one, H on the reactant side it is only one, Cl on the reactant side it is only one. But if you see on the product side, Zn is 1 but H is 2, whereas in Cl is also 2. You might wonder how it is possible. On the reactant side, whatever we have added, that only should come on the product side. But as you can see here, you can get Cl as 2, H as 2 over here. That doesn't make any sense. On the reactant side, it is only 1, 1. How come on the product side it will become 2? So that's what balancing equation explains. So how do we balance this equation? Very simple. So see, Zn is 1 here, Zn is also 1 here, H is 1 here, H is 2 here. So tell me, okay, well, balancing equation, what you have to remember is you have to multiply a number on the left hand side now, that is on the reactant side, any number x, okay, any number x you have to multiply so that you can get H as 2. So I'll multiply 2 only. 2 into H we have only 1, 2 into 1 that is 2. And 2 into Cl we have only 1, that is 2 into Cl, that is 2. 2 into 1 that is 2. Okay, so you might wonder why do we have to actually use a number which we have to multiply at the last of the last of the compound. Why? It is very necessary. Let me give you another reason. You cannot use your number just to multiply over here. Okay, you have to multiply, you have to always multiply at the end of the compound. That's how balancing equation works. So let me give you some another questions to solve from balancing equation. Let's see the questions. So let's start with some basic questions. I'll just write one more question here. We can just take an example as Mg. Okay, sorry. This one doesn't seem all right. Okay, Mg plus O2 gives MgO. So how do we actually solve this? Take Mg here, O here. So Mg is 1, O is 2. But on the right hand side, that is on the product side, Mg is 1, O is also 1. So how do we actually solve this? So as you can see, Mg is okay. Like Mg is 1 over here, Mg is also 1 over here. But what about O? See, O is 2 over here, but O is 1 over here. So I have to multiply some number so that I can get O as 2. So I'll use 2. I'll just use a number as 2. Okay, 2 into 1, Mg will also become 2. 2 into 1, O will also become 2. So now you might wonder, why don't we just put 2 over here and just multiply 2 into 1 and just write 2 instead of disturbing Mg? So that is not possible. The rule of balancing equation states that you have to use a number and multiply the number with a compound at the end of the compound, not in the middle of the compound. Okay, so as you can see here, O is 2 now, but Mg is 2, Mg is 1 now. So I'll use a number so that Mg can become 2. So that is 2. 2 into 1, it will also become So that's how it will gonna work. 2 into 1, it will also become 2. So that is balancing equation. Now we're going to talk about types of equations, type of reactions. We're going to talk about types of reactions. Let's get started without. Okay. So in types of reactions, usually we have 4 types of reactions. We have combination, we have decomposition, we have displacement, and we have double displacement. Combination in reaction in which 2 or more substance combined to form a single product. Okay, that is known as combination. Example, if you take a substance, something like A plus B, it forms AB. Okay, this reaction can be known as combination reaction. As we can see, 2 or more reactants, 2 reactants, but we have single product. Decomposition. Decomposition is nothing but something which one compound break down and give 2 or more products. Okay, 2 or more than 2 products. For example, if you can just take an example of this high example, that is AB give rise to A plus B. And in decomposition, we have 3 types. Decomposition, we have 3 types. We have thermolytic decomposition, we have electrolytic decomposition, and we have photolytic. So what are the difference? Thermo, as a name itself suggests heat. Electro, as a name itself suggests electricity. Photo, name itself suggests light. So what is this? Is nothing but if this reaction happen in the presence of heat, that is, this is known as delta, which represents heat, this triangle, small triangle, heat. So that would be known as thermolytic decomposition reaction. How do you define this reaction? Decomposition reaction in the presence of heat is known as thermolytic. Decomposition reaction in the presence of electricity is known as electrolytic decomposition reaction. Decomposition reaction in the presence of sunlight, as you can see sunlight on my face. Okay, so this would be an example. Decomposition reaction in the presence of sunlight would be known as photolytic decomposition reaction. Next, we have displacement reaction. Just take an example, A plus B. Sorry, let's erase this. Actually, my handwriting is not that great, but one thing I can make sure that the notes which I'm going to give in the description, that will be much more better than my handwriting. So AB plus C give rise to AC plus B. Here what happens, you can see the bond between A and D has actually broken and A has found a new bond with C. So this is very common in displacement reaction. This is what displacement reaction looks like. What is displacement reaction? So here, higher energetic elements displace less energetic element. So as in the reaction I introduced C, A thought ki B is not my level. Okay, I'll just make a new bond with C because my and C's energy will gonna match. So A thought to make a new bond with C, and hence it form a new bond, that is AB, and they abandon D. So this is what displacement reaction looks like, and this usually happens due to the difference in their energy levels, or we can say difference in their ionic levels. So that's what it happened. That's why it is happen. That's why it will happen. So we have something known as double displacement. Here, AB plus CD give rise to AC plus BD. So what here happening is nothing but, you can see AB is a bond, it's a compound, and CD is a compound. A is also breaking bond with B, and the C is also breaking bond with D. So hence A made a new bond with A made a new bond with C, and B made a new bond with D. So why it will happen? Cause it is due to the exchange of ions. Okay, exchange of ions, or we can say exchange of energy levels. So A thought my energy is matching with C, so A form a new bond with C, and B thought my energy, hence it is matching with D, so they made a new bond, that is AC plus BD. So that is known as double displacement reaction. This usually happens due to the mutual exchange of ions. This happens due to the mutual exchange of ions. Except that we have one more type of reaction. We have one more type of reaction which we're going to discuss in few minutes. Oxidation and reduction. So What do you mean by oxidation and reduction? Obviously, oxidation is nothing but either we can say it's addition of oxygen, addition of oxygen, addition of oxygen, or we can say removal of hydrogen. So you can see an example here where you can see Mg plus O2 give rise to Mg, or you can just balance this. If you write a balance equation, it will be 2Mg plus O2 give rise to 2MgO. Okay, this is a balance equation. So as you can see here, we are actually adding oxygen. We are adding oxygen. That is also known as oxidation. If we are removing hydrogen, instead of adding hydrogen, if we are just removing hydrogen, that is also known as reduction. Sorry, that is also known as oxidation. So for example, this is an example where we are actually adding oxygen. So I'll take one more example. So this is an example where you can see hydrogen has already been added. We are just removing hydrogen. This could be an example for reduction as well. So this is known as oxidation. Why? Either we have to add oxygen in the reaction or we have to remove the existing hydrogen from the reaction. So that is known as oxidation. In reduction, it is ulta. Either you can remove oxygen or you can add hydrogen. For example, you can see the removal of oxygen. If you just take this example like this, so as you can see here, oxygen is added already. So we are removing oxygen from the reaction and we just abandoned oxygen. So this is known as reduction. Oxidation is simple, very simple. Either you add oxygen or remove. Oxygen को add करना, नहीं तो oxygen को, sorry, hydrogen को remove करना. That is oxidation. Reduction उसका उल्टा. Oxygen को remove करना या hydrogen को add करना. That is known as reduction. So yeah, here the PPT looks very good, by the way. Very plain PPT. You can also take an example. But we have one more exception here. Oxidation and reduction together known as redox reaction. Again, oxidation and reduction together, if they occur, that is known as redox reaction. So the definition for that is also like that. Okay, what is redox reaction? You can simply say oxygen and reduction together known as redox reaction. That's it, not more than that. As to how, I hope you understand. If you didn't understand this topic, please let us know in the comments, and I'll also give you the link in the description for the notes. So I don't think so that would be a problem. So next we can discuss chemistry in our everyday life. So that is, we have two topics over here, that is corrosion and rancidity. So what do you mean by corrosion? You can say oxidation causes gradually destruction, or we can say rusting of iron is known as corrosion. You have an example of rusting of iron, that is corrosion, and rancidity is oxidation of fats. Let's discuss one by one. Okay, what is rusting of iron? So how does rust actually occurs? How? You just take any metal, keep in the direct exposure of sunlight, and also due to rain, it will also, due to rain, water will also fall on that metal, and sunlight, direct exposure to sunlight, this forms, okay, this forms, or we can say this forms corrosion. That is gradual destruction. This forms corrosion. So now we have learned how corrosion is formed. That is, if you keep any metal or its alloy in the direct exposure of sun, after that you are also putting some droplets on it. You are not putting droplets on it, okay, due to the rain, or it has exposure for moisture as well. So it will gonna form corrosion. The metal will get corrode. So what are the prevention methods for this? How do we prevent this? What are the prevention methods? How do we prevent this? So first, either you use paint. you do paint. Okay, for example, if you just go and see your some tanks, okay, like tank ऊपर का cap, if you see that, it will, like most probably it will be corrode in the rainy season. After rainy season, after sunny season, you can see it will get corrode. It will start getting corrode from one side. Okay, what you will do, what you will do for that? You'll just go, you will buy a paint, or you will just paint it, or paint, or by using lubricants. What is lubricants? Lubricants includes everything: oil, grease, everything. Oil, grease, and one more thing, by galvanizing. What is galvanizing? Galvanizing is a process of coating a metal with your desire element. Okay, so you can say desire metal. For example, if you just see a Olympic gold medal, do you think 100% it is made up of gold? Absolutely not. Before that, it was made up of gold. And you know, well, they used to bite the metal like this. That was it has become a gesture now. But on that days, like on older days, why they used to bite that metal? The simple reason behind that is to check the purity of metal. Because if it was made up of pure metal, you can see the bite of your teeth on the metal. But as you know, now it became a gesture, and now in the Olympics, even in Olympics, the gold medal is not made up of 100% gold. It will be like either they make it with silver or bronze, and then they'll just coat it with gold. So this coating of a desire metal, okay, the coating of a desire metal on your choice of metal, that is known as galvanizing. So by galvanizing also, you can also prevent corrosion. So these are the methods by using which you can actually prevent corrosion. And about rancidity, we're going to discuss. Rancidity is a process of oxidation of fats. So what do you mean by oxidation of fats? For example, if you just take a biscuit, you just keep it overnight. After you kept the biscuit overnight, what will happen if you see in the morning? So it becomes fluffy. The change in color, you can see the change in color, the taste changes, and the temperature of that biscuit will also gonna change. So this will indicate the rancidity, whether the person, whether the substance is spoiled or not. So how it will get spoiled? Due to the oxidation of fats. Oxidation of fats. So what are the prevention methods? We say uttarga, something which is uttarga, means something which is not ready, which is not good to eat now, because it has got spoiled due to rancidity. And you know, here you can also take an example of a chips. Chips, you can see, if you just open a chips packet, you can see there is more air than what chip is, like there is more actually air than what they have given the chips. Chips is very less in quantity, but compared to air. So what do you feel there? These people are scamming us? Might be, but the simple reason behind that is there are 2 to 3 reasons. First reason is they fill lace with nitrogen gas. Why? Nitrogen gas keeps the things fresh. Okay, but oxygen spoils it. But nitrogen keeps things very fresh. How it will keep things very fresh? Nitrogen is a type of gas which usually do not react with each and every people, but oxygen does. So that's why it won't react with the lace chips, and it will keep the chips fresh. But oxygen, if you put oxygen, it will gonna react with the lace, and it will get eventually get into this process of rancidity, and it will gonna get spoiled. So what are the prevention methods for rancidity? Either use a close tight container, close air tight container, use close airtight containers, or you use you just cover your eatables in the nitrogen gas, and just what we can say, cover your eatables in the nitrogen gas, and just keep it in a closed container, and avoid keeping the food outside. And one thing, after this class, you can see in the description, I'll be adding most important and most repeated questions from this chapter, specifically for your upcoming board exams. You can just go ahead and try to answer them. And also, I'm going to also provide the notes for you. So don't worry. And in the common, if you see two types of reactions we have, okay? Commonly, if you see, we have two types of reactions. We have two reactions. Actually, we have four, but this is like common reactions. That is one we have exothermic, and one we have endothermic. What is exothermic? Exothermic is nothing but the reaction in which heat is released. Endothermic is reaction where heat is required. So that's it for today, and let's see you in the next class. And if you have any suggestions for me, please let me know. And I hope you enjoy this class. And you can see your PDFs, and the most important questions will be there under the description. Just view it and practice. Let's see you in the next class.